All right. Welcome, everybody, to Lesson 7. How was everybody's preparation?
Good.
Yeah, I didn't think it was super complicated.
It was lesson 7, right?
Yeah.
Yeah.
Okay. Was it pretty much a review of what we've done?
Yeah.
Yeah.
Sort of.
Yeah.
Yeah, I would say kind of, except for they added the sample, right? The sample mean, how to.
Yeah, like getting the z-score for the sample mean distribution.
Yeah.
Yeah.
Yeah, I think it was review of Lesson 5 and Lesson 6, if I'm not mistaken. I mean, that's what the videos were about and stuff. Review and then the mean response.
Yep.
Were there any questions that kind of stumped you at all?
No, I think at first it was like in the story problem, I had to kind of get used to the terms, like what were they asking? Like if it said probability or if it said like find the area, well, that's the same, isn't it? Finding the area and the probability, is that the same?
Yeah, when we use like the applet.
Yeah. Okay. So yeah, I just kind of had to, and then if it said, what's the shape, what's the, I just had to kind of figure out what they meant by each of those. But then once I figured that out, the shape, the, come on guys, help me out. The shape
of the distribution.
Yeah, like it some of the questions asked for all three, it said, what's the shape, what's the distribution, what's the,
right.
Yeah, I don't know. I have to find one like that. But anyway, yeah, once I got past that, then I think it made sense more.
Cool.
Do you think we're ready to jump into the quiz then?
I
Sure.
think I'm ready.
Yeah, sure.
Okay. Is the first one 0.175?
Yeah, that's what I got.
Yeah. That's what I got too. I mean,
Would 4 be the distribution of sample means?
That's what I was thinking. Because to get the distribution of the sample means you have to divide it or whatever. So that would make it smaller, if that made sense.
Mhm.
So what was it, the second one or the third one? Oh, the second one. No,
Yeah.
Wait.
because it's smaller.
Distribution of the
Sample mean. Okay. The following.
Would 5 be the law of large numbers?
Yeah, that sounds right. 'Cause
Yeah.
Isn't the law of large numbers is like the bigger your sample size gets, the closer it gets to the mean?
yeah, I'm pretty sure. Yeah.
the spread to the
Uh-huh.
X bar. I was calling it X box last week. Sorry, X bar. And you guys didn't correct me. You just went along with it.
It worked.
Yeah, we all knew what you were talking about, so it's all right.
Okay. Use the following information as an explanation. Okay. Okay, so you just take 160 minus 150.8. All right.
Yeah, and then divide.
Over divided by 8.8. We're just doing like the regular z-score, right?
I think so.
Would it be 1.045?
Yeah.
1.045.
Yep.
Did you guys get 0.148 on question 7?
Yes.
Oh, because what you did is you just took the z-score, or no?
Yep.
Oh, and just plugged it in?
Yep, just
we-
put it in the applet.
Right, because we already had the z-score.
Yeah.
Okay. And what was it again?
0.148.
Okay. Here's the random sample one. Okay, random sample 5.
Eight the same as the girl that we did, 1.045 for the z-score.
What, don't we have to do the because it's a random sample. Do we have to do that new? Or that other formula? Is that right or not?
I don't think
Not on this one?
Because the mean of these 5 is 160.
Okay.
And then to get the z-score, you use the population mean for the GRE, which is 150.8.
Okay.
And then divided by 8. So I think it is the same as 6.
Okay.
Hmm.
1.045.
Yes.
And question 9 would be the same as question 7, wouldn't it?
Would it be different because it gives 5 randomly selected students?
Mm.
I don't think so.
What's the problem?
This one also says turn the decimal to 4 places.
Was the other one? Wait, hold on. Let me think for a minute.
Oh, I think question 8. I think we do use the new formula on question 8.
Yeah, because
Yeah.
n equals 5, right?
So we find a new standard deviation.
Well, I think we do the 160 to minus 150.8 divided by 8.8 divided by the square root of 5.
Yeah, because it doesn't matter what their scores are, right? It's just that they're random.
Yeah, because it's taking a sample, so it's asking. Yeah, because in the question is what is the z-score corresponding to the sample mean?
Mm-hmm.
So it's supposed to be. Okay, so what's the top again? 150.8 minus 160?
Yeah. Wait.
Or is it over?
I think it's 160 minus 150.
Yeah.
Oh, the other way.
One
Yeah.
second.
150.8 is the mean. Okay, yeah.
The population mean.
And then the bottom is the standard deviation divided by, right?
Yes.
Divided by the square root of
5.
5.
Yeah.
Okay, so the standard deviation. Okay, so 8.8.
So what did you get for number 8?
let's see. So so 9.2 is the top, right? And that's over 8.8 divided by the square root of 5 is the denominator.
Yes.
We'll divide that by 9.2. So I got 0.4277. Is that what you guys got?
What did you get?
0.4277. Or how many do we have to go? Or 0.4278, because it's. What did you get?
I keep getting an answer every time I do it. So, like a different answer. Mm-hmm.
You say you got 0.468?
Oh, wait. Hold on. So 9.2 divided by, right, 3.935. Is that what we're doing? Okay, no. That time I got a different answer too. That time I got 2.338.
And that's what I just got.
But the probability.
Oh, that's just
well, if it's asking for the z-score.
The z-score.
Oh,
For 8. So would that be the z-score?
Yeah, it's the new one. Let's see. What's it asking? Yep. What is the z-score corresponding to the sample mean? So there's like the regular z-score, and then there's a z-score that corresponds with the sample mean. So it changes, right?
Yeah.
Mm-hmm. So on 9, what is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem?
Okay, let me see. So the probability.
Wait, I'm sorry. What was the answer to number 8?
Oh, are we put 2.338. Right, Leah?
Okay.
Yeah.
I don't know if I'm positive about that, but I think so.
2.338.
Mm-hmm.
I just got to.
Wait, 2.338 or 0.2338?
2.33.
Okay, yeah. Okay, thank you.
Mm-hmm. And for the second one, I plugged it into the applet and got 0.0097 for the area.
Yeah.
And then highlighted it to the greater than, right? Let's see. So you just plug in that 2.338, and what did you get?
0.0097. I highlighted the right side because it's asking for the greater than.
Yeah, okay.
Are we ready to move on?
Yes.
Yeah, I'm good.
Okay. So the next one is, suppose the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. It is well known that the distribution is left skewed. A random sample of n equals 81 students will be drawn. What is the shape of the sampling distribution of the random variable, which represents the sample mean of the 81 students who are selected?
Approximately.
Yeah. What is the mean of the distribution of the sample means, sampling distribution, for all possible samples of size 81 that could be drawn from the parent population? And wouldn't the mean be the
It's always the same, right?
Yeah, 3.5.
Yep.
What is the standard deviation of the distribution of the sample means for all possible samples of size 81 that could be drawn from the parent population?
Standard deviation of the distribution of the sample. So it's the new.
The standard deviation is 0.7 for the parent population.
Okay, so we have to find the new one, right?
Yes. So would it be 0.7 divided by the square root of 81?
I think so.
And I got
Yep.
0.078.
Divided by 9. 0.7. 0.7.
Oops.
So to go back to question 11, so the mean of the sample means of the distribution of the sample means, that's always the same as the parent population mean?
Yep.
Okay.
Yes.
You know how they described on the video that it has like the mean of the mean is always the mean or whatever. I don't know how you explain that, but yeah, it's always the same.
Okay.
Okay, wait. So the one we just did. Oh, let me just look at that real quick. 0.0078 probably.
Yeah.
Or is it saying 3 decimals? So what is it? 0.008?
0.078.
Oh, I think I'm wrong. Oh, is it point? Okay, I just did it by the wrong. I did the top wrong.
Mm.
Okay, I got it.
So when it asks what is the probability that the mean GPA for 81 randomly selected BYU Idaho students would be less than 3.3, you plug that into the other formula with the new standard deviation, correct?
Yes, because it's talking about the randomly selected students. That's less than. Okay, so.
So I got negative 2.56 for the z-score, which brought out as 0.0052 for the probability, but it only asked for 3 decimal places. So now I'm worried that I'm wrong.
Hold on 1 second. 2.3
So you took the new z-score, 0.078, right? And just plugged it in and then highlighted less than?
Yes.
Is that how you got that? Okay.
Mm-hmm.
What did you guys get for it?
For 13, I got 0.005, and 14 was 0.995.
Okay.
Okay, so we have the mean is 185, right? Are we on 15? Okay. And then we've got the standard deviation is 26.7. The random sample, which is n, equals 48. And the sample mean, 177.6. Find the probability that the random sample of passengers will have a weight that is This one's throwing me off. I don't know what they mean by adding the sample mean in there. You guys get that? So you go 177.6 minus 185 over, because we need to find the z-score.
That's
first.
what I do.
Yeah, because then we need to find the, okay.
Yeah, because the sample mean is the x over with the line over it, right?
Mm-hmm.
Like that's the.
Yeah, with the square root, you mean?
No.
No.
Like
Okay.
in the formula, how it's like x with line over it minus the u thing.
Oh, x bar. Yeah.
Yeah, that x bar.
X box. Okay. So are we in agreement that we do 177.6 minus 185? Or is it the other way around?
Yeah, that's right.
Okay. So minus 7 or negative 7.4 over 26.7, right?
Uh-huh.
Divided by
Square root of 48.
Okay, so let's see. And the probability.
I plugged the z-score into the applet and got 0.055. Does that sound right?
Oh, wait, let me do it again. So
did you click on the areas to the left and to the right?
Yes.
So that's what I got as well then,
Okay.
0.055.
Mm-hmm.
So for your
What
z
is-
square, you got negative 1.92.
Yes.
okay. Let me see. So negative, sorry, I'm back at the z-square. Negative 7.4 over 26.7 divided by the square root of 48. Is that right?
Yeah.
Okay. And you got negative 1.92.
Yes.
And you plug that in. And you highlighted around each, or
The extremes.
And
Yeah.
extreme and more extreme. So where do I highlight?
So on each side.
Okay. Leave the middle open.
Yeah.
Okay. Okay. Yep. 0.055. Okay.
So
Are we ready to submit?
can we go through the last couple of questions real quick? Just
Yeah.
so I can make sure that I have the right answers.
Where do you want to start?
So for let's just start at 11, if that's all right.
Yeah.
So 11, I got 3.5. Is that
That's what I
right?
got.
Okay. And 12 was 0.078.
Yes.
Yeah.
And then this is where I was kind of like more question. 13 was 0.005.
Yes.
Okay.
Say that again. 0.005.
Yeah.
Perfect.
And then 14 was 0.995.
Yes.
And 15 was 0.055. Cool. All right.
Do we have to have that 0 on the front, do you think?
I don't think so, because I've put in answers without that 0 and still gotten it right.
Okay. Okay.
100%.
Nice.
Cool. Great. All right. Well, we'll probably, I guess, of course, we'll meet again on Tuesday, same time.
Sounds good.
And next week is the exam.
Oh,
So that'll be exciting.
How did-
I think
how did you find that? Is it on our calendar?
so I went into the table of contents and I just looked at what next week 5 had.
Oh, smarty pants. Okay.
Yeah. Yeah, it's actually in the first part of the week too. So like on Tuesday we have the group meeting quiz, and then the Unit 1 exam is also in that Lesson 8 section.
How long is it open for?
It's open. It starts February 5th and it ends February 7th, so only 2 days.
Wow.
Yeah, so that kind of will be fun. It'll be fun.
Do we get to meet together? I mean, I know we can't take it together, but do we get to meet?
Yeah, because there is still a lesson next week for
Okay.
that time. Yeah, it's Lesson 8. Everything's the same, except the homework is just studying for the Unit 1 exam and then taking it.
Oh, yikes. Okay.
So, yep, just, study lesson 8 and then study all the other lessons too.
Yeah, well, good luck. Oh,
right.
all right. Well, thanks, everyone.
Yeah, thank you. Have a good weekend.
You
Yeah,
too.
guys.
Bye.
Bye.